me just tell you guys a little bit more about myself. My name is Jessie, and I probably, many of you probably have seen me before. We're in the Bay Area. I'll move on to Elijah. I actually know him for a number of years already. Even before we started Create and Learn, I actually talked to him, get a whole bunch of advice about how do we teach data science to students like yourself. So he gave us really good ideas, and I'm so happy that today he's actually going to come talk to you guys about data visualization.
Wonderful. So my name is Elijah Meeks, and today I'm going to talk to you about data visualization. I'm going to talk to you very specifically about a category of data visualization, which is called network visualization. And in doing so, I'm going to talk a lot about networks. So my focus today is going to be on how networks are represented as diagrams, but we'll also talk about how networks are used in data science. And you'll notice this beautiful little bear over on the side here. He's a first anniversary bear for the Data Visualization Society. And he's wearing a very interesting outfit with a very interesting hat and a very interesting tie. And there are some secrets about this bear that eventually, once you've watched this whole presentation, hopefully you'll know. And we'll revisit the bear at the end. So before I get started, I want to talk a little bit about myself. I've worked at Stanford, where I worked with historians and philosophers and people who study literature in what's called digital humanities, which is using data science, data visualization, and those kind of things, but to study history and philosophy. I also worked at Netflix for 5 years, where we built all sorts of interesting data visualization projects, including visualizing algorithms, visualizing how people navigate Netflix, what shows they watch, and so on. And then finally, more recently, I've been working at Apple for 5 years. I mean, sorry, not for 5 years. My goodness, that'd be impressive. For 5 months. At Apple, I do roughly the same thing, except I work with Siri. So I look at how Siri performs, and we use data visualization to understand that. And finally, I'm also the executive director of the Data Visualization Society, which is a professional organization focused on data visualization and the people who make data visualization. That's my Twitter username, so if you ever want to ping me on Twitter, feel free to. So I'm going to talk about networks today. I'm going to talk a lot about networks and a lot of different kinds of network. But first, before I do, I want to talk about data visualization itself as a broader subject. So there's a lot of different kinds of data visualization out there. These examples on this page are just a few of those. And the different ways that you can take data and you can apply that data to color and shape and size and position are almost limitless. It's a really exciting field to be in. And every year it gets more and more complex, and more people who do data visualization are hired by these big companies like Netflix and Apple, and universities like Stanford spend a lot of time studying data visualization, trying to figure out what the effective kinds of data visualization are there. You probably know what kinds of data visualization these are. Can anybody in the chat tell me what we've got over here on the right? It's a chart, and that's a good, cheap guess. Of course, it's a chart, it's a graph. This particular one is a line graph, and I've seen a lot of people say that, a line chart or a line graph. That's perfect. And I can see everybody, now that the chat's back and open, I can see that everybody said, yes, we've got a pie chart, we've got a bar graph, and a line chart. So I want you to stop telling me what they are, and I've got another question for you. What do all three of these charts have in common? No, none of these are PewDiePie, I'm sorry. They measure data, it's true, they're all charts, they display data, but more specifically than that, what kind of data do they display? What kind of data do they measure? There it goes, I saw somebody mention it. They measure numbers. So that's what's really great about charts like a bar chart or a line chart, is that they measure numbers really well. So your eye and your brain is very well designed for measuring things like these bars on this bar chart, or measuring the distance between the points on a line chart. You can tell not only that the bar on the left is bigger than the bar next to it, but also you're really good at telling just how much that bar is bigger than the other bar. And that's why these charts are so common, because a lot of the data we work with is numerical data, it's numbers. And in fact, it's so common that a lot of people who I work with only think that data is numbers, and you might think that too. But there's more kinds of data than numbers. And I'll give you an example. What is this? What is this that I'm showing here? Yeah, exactly. It's a map. These are countries in the world. Now you look at this map. This is a weird map. It's pink and blue. It's all sorts of scratchy design and everything like that. And yet you immediately knew it was a map, even though this map doesn't look anything like this, right? This is the real world. If you look at the world from space, you can't see all the countries at the same time. You can't see all the continents. You can't see all the oceans. You can only see one side of it. And really, you don't live in space. You live here. This is the Central Valley where I grew up. You never see anything like countries or continents in your everyday life. And yet you already knew that that map was a representation of the world. And you knew that because you've learned that in school, and you've learned that from your parents and your friends, and you understand maps. So it's really critical as we look at these networks in this presentation today, that you remember that even though these maps on the screen here are all very different and very weird, that you still understand that they're maps, that they represent the world in one way or another. So I'm going to show you a bunch of things during this presentation that are very weird and very abstract, but they represent the real world in a different kind of way. So keep track of that as we're moving forward. Now we've got the map, that scratchy map that I produced, and these maps that show hotspots and a classic map of geography. And then I love this map on the bottom left here. It's a shortwave radio map. And you people probably, because of your age, aren't really aware of what shortwave radio is unless you've seen Stranger Things. Shortwave radio was how Dustin in Stranger Things talked to his girlfriend in season 3. So let's move on to networks. What are networks? Well, networks are actually a very simple concept, much more simple than geographic maps like that. Networks, well, he claimed to have a girlfriend in season 3. She might have been imaginary. So networks are a really simple concept. You have two things, and those two things could be anything. So they could be you and your friend, and you draw a connection between those two things. That's what a network is. So in this case, this is a connection showing that you are connected to another person by friendship. And this is the building blocks of a network. And you can do this with all sorts of things. So you could say that your town that you live in is connected to another town by the freeway. That's another kind of network. And this is from these very simple rules, those very small building blocks. You can create much more complex structures. So if you had many people and you were looking at how they were friends with each other, you'd see a much more complex shape than just two circles in a line. And if you wanted to include maybe people who had many friends, or cities that were connected to many other cities, or just anything that's connected to many other things, it becomes more and more complex. And it gets so complex so quickly that when you look at something like this, which was a map of Twitter that I did back when I was at Stanford, then it looks like some kind of background graphic for Into the Spider-Verse. But it's not. This is actual data being represented with network data visualization, showing how people are connected to each other on Twitter based on how they're tweeting at people. And there's lots of different ways to build networks out of data like Twitter data and Facebook data, and that's one of those ways that we use. So what are some kinds of networks? Well, we've already talked about what we call social networks. So social networks are networks where people are connected to each other for some reason or another. You are connected to your friends. People who work with each other are connected with each other if they work on the same project together. People who write a book together are connected to each other. These are all sorts of different ways that we can build social networks. And in fact, this is the reason why when you go out and you go to parties with business people who are in the same business as you are so that you can get to know them, so maybe you can develop business contacts with them, we call that networking. But there are other kinds of networks too, besides the ones that we've seen. So for instance, a food web or a trophic network is a network where animals are connected to each other based on whether or not they eat each other. So remember your favorite animals from when we first started this presentation. We know that they're connected to each other in a network based on the fact that they eat each other. So when you read this network diagram, can one of you tell me, why is it that the rabbit is connected to a hawk with that arrow? What does that arrow mean? The circle of life, you're absolutely right. The hawk eats the rabbit, that's right. But why is the hawk then connected to bacteria? Why would the hawk and so many other animals be connected to bacteria? Exactly, somebody said it in there. It's decomposition. When an animal dies, the bacteria eats it. And then the bacteria gets eaten by these different plants. And that is, like somebody said, the circle of life. So that's a network. Another kind of network, if you go talk to someone, for a lot of people, the first thing they think of is a computer network. When you look up in your browser and it says HTTP, that means hypertext transfer protocol. And that's a network protocol. And that's because a computer network links together computers and servers and other kinds of things through wires and through wireless ways of communicating with each other to connect to the internet and to connect to local networks and all sorts of things. So a transportation network is another kind of network. Cities are connected to each other by highways and airports. If you grow up in a big city, you probably have a subway system or a bus line. And so you've probably seen these maps of how your subway system or your bus line connects different parts of that city or different cities together. This is a network diagram. This is network data visualization. A vascular network. Your whole body is a network. It's a network of veins and arteries connecting organs and tissue. And as someone has said in the chat, your brain is a network of neurons connected to each other. And these networks are used by scientists and medical researchers to model and better understand how the human body works. What are some other kinds of networks that you can think of? I see somebody saying neuron networks in AI. It's neural networks, and that's another way of doing AI is with neural networks, absolutely. And that's a way of modeling things. A wide area network, that's a part of that computer network that I was talking about. The electrical grid is a network, that's a great one. I don't know what a network of plugs is, that's very interesting. The sewage system, exactly. Sewage system is exactly a network. So someone had mentioned the electrical grid. The electrical grid is very much a network. There are cables, giant undersea cables that connect different parts of the world that allow information to travel between them. You might think that all of our data passes through satellites, but it doesn't. It actually, a lot of it goes through these undersea cables. And so you have to, let me ask you actually before I say it, why do you think networks are important then? What's so important about doing data visualization of networks? Why would we even think about networks? So to connect, some people say that they connect us, absolutely. But what can we understand by looking at how things are connected? These are fun answers. So someone said how stuff works. It's an interesting concept, right? So when we think about how people are connected to each other in something like this knowledge graph, right? So a knowledge graph connects different people, in this case, a singer and her brother and her mother, but it also connects her to the things that she's created, the things that he's created. You can think about Pokemon networks. You could connect Pokemon together based on whether or not they have shared attributes. They share the same types, right? So some Pokemon have one type and some Pokemon have multiple types. And what that allows you to do when we look at networks, things you can do with networks are you can predict the future. And that seems like a rather bold claim, but actually, when we look at a network like this, and this is a famous study from network science, for those of you who are in sports or who practice martial arts, whenever you're on a team, you might be on the same team, but not everybody gets along with each other as well. So this is a network from a famous martial arts club back in the 1970s. And what happened in this club was that two people got upset with each other and one person left the club. But that person was such good friends with some of the people in the club that those people left with them. And so what happens is, if we look at how those people were connected to each other based on whether or not they spent time with each other and they socialized with each other, then you can actually predict, when this club splits into two, exactly who is going to leave with the same people. So networks allow you to predict the future. Networks allow you to predict the kinds of songs that you want to listen to. So they know that you listen to this kind of song and that kind of song. And because other people who listen to this kind of song and that kind of song also listen to a third song, then they'll recommend to you a song. This is how Spotify works. This is how Amazon works. Networks allow these companies to predict what kinds of things you want to buy, what kinds of things you want to listen to, what kinds of places you want to go. But another way that you can predict the future is that you can predict with that trophic web that we saw, that the food web or the trophic network. You can predict that if you remove certain animals from that network, then it has other effects on an entire system. So those of you who are interested in becoming a biologist, you might have heard that wolves were taken out of Yellowstone. And when they left Yellowstone, what happened was what's called a trophic cascade. So because wolves weren't around to eat the elk ate much more of the plants. And as a result, the plants weren't there to hold the soil up, and the soil fell into the rivers and backed the rivers up. So because wolves weren't around, plants and the rivers were affected by it. And that's because in these networks, we see a system. So you can use networks also not only to predict the future, you can use networks to find paths between parts of that network. Now you use networks, or your parents use networks all the time, because that's how Google Maps and those kind of applications operate. They tell you to get from one place to another, not because they understand maps, but because underneath they're made out of networks. So when I was at Stanford, we built another network just like that. We made a Google Maps for the Roman Empire. And what it allows you to do, and this is at orbis.stanford.edu if you want to play around with this, is it allows you to pick one city in the Roman Empire, and you pick another city in the Roman Empire, and it will plot a path between that city and the other. So what we're looking at here is how Rome is connected to London during the summer. And during the summer, you can sail across the coast of Spain. And so it's very cheap to get from Rome to London. And it only takes about 30 or 35 days. But in the winter, if you want to go from Rome to London, you can't sail along the coast of Spain because the weather is terrible. And so you have to go overland. It takes 3 times as long and costs 10 times as much. And so we understand now the system of the Roman Empire better because we understand how it was affected by changes in time of year and cost, and how people could move from one part of it to another. So that's why pathfinding is so important. It's not just important so that you can find your way to the store you want to go to. It's actually also important for understanding how things are really close to each other and not just close on a map. Another kind of path that you can find in a network is paths between people in genealogical networks. So I built another application at Stanford. It's at kindred.stanford.edu, and it's called Kindred Britain. And it has thousands of people who are related to each other. Many of them are famous people. And even though it's called Kindred Britain, it has many Americans in it, like President Kennedy and President Jefferson. So President Kennedy was president in the 1960s, and Jefferson was president at the very beginning of the United States. And we can see that John F. Kennedy is related to Thomas Jefferson because John F. Kennedy's sisters, husbands, fathers, mothers, fathers, sisters, daughters, husbands, fathers, sisters, husbands, fathers, sons, wives, brothers, wife was Thomas Jefferson's son. I'm sorry, daughter. That was his daughter. And so you can see these connections between people. You can see these connections between places using networks. Now, when we look at networks, when we create network diagrams, we use a lot of the same methods and a lot of the same terms. So here are some of the terms that you'll hear if you study network organization. These lines and people, the city, But what we typically refer to those symbols as, those circles, we call them nodes. And so if you're a person in a social network, then that person is called a node when we're creating a network diagram. And those connections between them, we call them edges. And sometimes those edges are in a particular direction. Well, remember when we were looking at that food web, that the rabbit was connected to the hawk, but the rabbit was connected to the hawk with an arrow because the hawk eats the rabbit. That doesn't necessarily mean that the rabbit eats the hawk. And so you can see this in your everyday life. If you're on Twitter and if you're on Facebook and you're friends with someone on Facebook, then you're both friends. It goes both ways. But if you follow someone on Instagram, that doesn't necessarily mean that they follow you. And so that direction of a network determines what kind of network it is. So if you see arrows in a network, that means it's a directed network. And if you don't see arrows, then that's what they call an undirected network. And different kinds of networks allow you to do different kinds of things. Now, when we say node, typically we refer to those circles as nodes. Sometimes you'll also hear them referred to as vertex or vertices. And when we talk about edges, sometimes they're called edges, sometimes they're called connections, and sometimes they're called links. And that's why this kind of chart is oftentimes called a node link diagram. So another thing that you can do with networks is you can measure the power of something in that network. So if all of these circles were people and they were connected to each other based on being friends with each other, then who's the most powerful person in this network? No, you're not, because you're not even in this network, Sean. Right. The middle one, you immediately saw that. Even though this is the first class you've taken on networks, you immediately saw that this person here is the most powerful. And why are they the most powerful? Well, they have 4 friends, which means they have the most friends. They have 4 and nobody else has 4 friends. But more than that, they're friends with people who also have friends. And so that means that they have a certain kind of power in a social network. If you were this person over on the end here, and this other person on the left knew of some kind of internship at Google, then who would you have to talk to be able to talk to this person? You'd have to talk to your friend, who talk to their friend, and they'd go through this person at the middle here. So that's another kind of power that most of the time, if you wanted to talk to anybody else on this network, you're probably going to have to go through this person in the middle. And so that's one way of defining power. There are many different ways of defining power when we look at networks and network diagrams. Sometimes it's referred to as centrality. The other thing we can look at when we see networks is we can see the communities in the network. Now, earlier I had said that karate club split into 2 groups. We call those groups communities. And even if a network is very connected, you can still identify the communities that exist within it, because people are more strongly connected within certain parts of the network than other parts of the network. And so in a network like this, where people aren't connected at all, you can see that there are these groups of people who have friends that don't know anybody in that larger group over there. And so that's another thing that we can measure and we can see with network visualization. So what types of networks are there? Well, we've spent a lot of time on node link diagrams. And these are typically used for things like social networks. So we can see a node link diagram. This was in the New York Times about 6 or 7 years ago. And it connects actors, it connects directors, and it connects producers if they've been working with each other on the same movies. Here's a network of people in Singapore who are connected to each other. This is another social network, but this one is connecting people who caught COVID-19 from each other and what areas in Singapore they're related to. So I have an exercise for you to do, either now or later after this presentation. I want you to go and sit down and draw a circle at the center of a piece of paper, or use your iPad and draw it center there, and label it as you. And then draw circles around it who are your friends and connect them based on the kinds of conversations you've had with them in the last few days? Have you said things to them on Twitter? Have you said things to them on Instagram? Have you actually called them? And then after you do that, ask some of those friends who have they talked to in the last few days and try to connect them too. And try to draw your own node link diagram. So when you do that, you'll find out that drawing these diagrams is very, very difficult. And that's why we use all sorts of methods to draw them with computers. We use what's called a force simulation that pushes away each node from each other, each person from each other, and pulls together the ones that are connected to each other. These are all different kinds of networks, but they're using much the same methods, regardless of whether or not they're networks of people connected to each other or networks of books connected to each other. So those were node link diagrams. Another kind of diagram is a hierarchical diagram, which is something like this. And you can see that it has much more of a specific kind of structure. What do you think that we would use these hierarchical diagrams for? So that's exactly what hierarchies are used for. They're used for things like organization charts for companies. This is an organization chart from 175 years ago from the New York and Erie Railroad. Here's the president, here's his board of directors, here's his vice presidents and his managers and his directors, and they're all connected to the people who report to who, all the way down to the very end of the line where the person who's working on the train or the railroad track is connected to their managers. Another one that people already mentioned was that you can make family trees with hierarchical diagrams. And you can make family trees in all sorts of different ways, but I want to talk about two simple ways that we can make them. You can either take yourself and you can draw a line, you can draw the hierarchical networks so that it goes from you up, and so you draw your parents, and then you draw their parents, and so on and so forth. Or you can do something like pick one of your grandparents and draw down, and draw who their children were and who their children were until you get to yourself. And you'll notice on this chart that you'll see that there's only one grandparent and only one parent. And that's because in a lot of the hierarchical data structures that we deal with this kind of network visualization, you can only have, a node can only have one parent. So we have an exercise here that I want you guys to work on. So on your own, whether, like I said, you're using an iPad or a piece of paper, pick one of your grandparents and draw them at the very top of the paper, in the middle of it, and then draw all of their children with those same lines, with that same sort of hierarchical structure that we've got here, and then draw all of their children. And take a look at how that works, and then compare that with this link that hopefully you'll see shared in the chat. This link is to an observable notebook. This is using JavaScript and a library called D3 that a lot of people use for network data visualization. And that allows you to draw that same diagram, except using code. So I've already added in some of the code here. This is my family. So I picked my grandfather. His name was Thurston. He had 4 children, Selena, Yates, Philip, and Truett. And Philip was my father. He had 5 children, and I'm one of them. And you can see the data structure here. And if you want to, you can go and adjust it. I know that Truett had a child named Pam, who's my cousin. And so if I go and add that in there, and I hit this little play button over here, you'll see that the diagram over here updates. And so we have my grandfather, Thurston, and then all of his children, right? And then all of their children. And so we see this hierarchical diagram that allows you to, instead of drawing by hand, draw using code, these things like family trees. And this entire notebook is full of hierarchical data and hierarchical data visualization if you're very interested in that kind of thing. But what I would love is for you to draw those by hand and then draw those using that code and then post them and at Data Viz Society on Twitter or Instagram, or post them on Facebook, and let us see what you were able to draw and how maybe you have improved on some of the methods that you've seen here. And you'll notice when I refresh the page that it no longer says anything about Elijah or anything like that. Instead, it looks like this, where it says root and child 1 and child 2 and grandchild 1 and 2. So what you can do is instead of root, you can add your grandparent's name. And you'll notice that nothing changes when you do that. But if I hit the play button over here, it updates it. And now it says my grandfather's name. And so you have these children, child 1. So you can change the names. And when we update it, we see that the names change up there. If you want, you can take this block of code here, and this is what's called an object. These curly brackets designated as an object. It has a property called name. You can copy it and you can paste it. You can change the name to another child of your grandparents. My grandparents had a few kids. So Yates was another one. And then if I hit play, then I'll see that now Yates shows up there, and I can add another one. My other uncle's name is Truitt. And then my father's name, he had some kids. Their kids were not named grandchild 1 and grandchild 2 and grandchild 3. Their names were Nikki. But the last thing I wanted to show you was that notice that this object with these brackets around it just says name Elijah. If I add a comma to it, let's take my sister, and I add children, and then I give it an array, which is these square brackets, and I put in that the curly brackets, which is another object, and I tell it name, and I give it the name of my niece, and you'll notice that it adds a child to that node on the chart. And that's how you can build out these hierarchical networks. This is, I know that for some folks, there's you know, it's going to be more challenging to write code like this. You might not have experience with JavaScript. This might be your first time playing with coding. So give it a try and take a look at it. But I'm going to get back to the presentation now, okay? All right. So I'm going to not spend too much time on this next kind of chart because I think we are getting close to our brains being full. But I want to draw your attention to something else called a flow diagram. And so these flow diagrams, and this particular one is called a Sankey diagram, are about showing amounts of things flowing into other things. So if you imagine rivers flowing into an ocean, where first they flow into lakes and then they converge and diverge, it's a diagram much like that. And these kinds of diagrams and these kinds of networks are typically used for things called funnels. So if you think of when you go to a website like Amazon, some people, it's fewer and fewer as you go through that. And that's what's called a funnel. And funnels are everywhere. Everything in tech runs on funnels. You, as you're working on this, as you're watching this presentation, you're part of a funnel right now. And we represent those funnels oftentimes with bar charts like these. But then in reality, it's not as clean as that because people don't go from one step to another. In reality, they jump all over the place. And so we have to use more complicated diagrams to represent that. So here's my last exercise for you. And it's not one that we're going to do here, but it's one that I'm going to offer up that you can take with you and you can go and do while you're stuck in quarantine or social distancing, which is that typically when you're young, you think that you're going to go through the world in one direction. You're going to go to high school, and then you're going to get a bachelor's degree, you're going to go to college, and then you're going to get a master's degree and a PhD, and then you're going to go to work, and you're going to be a data scientist at Apple, and that's how it works. But that's not how real life works at all. Instead, oftentimes people go straight to work out of high school, or they go to work after getting their bachelor's degree, and then later on they come back and go get a master's degree. And so what I would ask you to do is go and interview your family members, interview the people who you know who are already working, and ask them, which ones did they do first? Did they go to high school and then get their college degree and then go to work, or did they go to work first? And then try to draw some of these flow diagrams. And if you do that and take some pictures of it, then share them with us on, like I said, at the Data Viz Society on Twitter or Instagram or on Facebook. So that's a lot. It's a lot of networks. And now we're back to the bear. And so now maybe as you look at that bear, you realize that he wasn't just wearing silly pajamas. The bear was wearing actually an outfit that's full of network diagrams. Not only all of these node link diagrams, right, which are all over, but also this diagram here is a sunburst. It's another kind of hierarchical diagram, much like those trees that I showed you that we looked at family trees for. So hopefully you have a little more respect for our little teddy bear, and you have a little more love for networks and interest in doing network data visualization and reading more about it and learning more about it. And I think at this point, we can open it up for questions if anybody has any questions. So someone asked, is network connected to a radar? And radar is connected to networks in many different ways. First of all, the way that radar works is to send out a pulse. And if that pulse hits something and comes back, then it makes a connection with something. But the radar themselves, the devices that run radars, that whether it's radar for air traffic control or in the military, are connected to each other, and they're constantly linked to each other and updating where things are based on hitting that same thing from many different directions. And so it's very related to radar. Someone else asked, how did you create the Twitter diagram? I used a tool called Gephi. It's one of my favorite network visualization tools. I used to work with the Gephi team for a while. It's what you need to use when you want to look at very large networks. So most of the time when I build network data visualization that runs in the browser, we deal with small networks, so networks that are only 100 or a few thousand people. But if you want to build a network that is 500,000 people or 500 million people, then you have to use specialized tools. And one of those tools is Gephi. It's spelled G-E-P-H-I. So someone else asked, how do they get the cables into the ocean? Big ships take them and they drop them and they anchor them down. And they've been doing it for 100 years. They used to send messages across those, and now they send the internet across those. Would genetics be considered to be a network because they connect us to our ancestors? So in many different ways, genetics is a network. Network analysis and network visualization is used quite often in genetics, both in the very straightforward way of looking at family trees, and there are some amazing family trees out there, especially for kings and people for whom we know a lot about their ancestry, but also in looking at how proteins interact with each other. They use network analysis and network data visualization for that. And a lot of different parts of the body, because so many parts of your body operate as networks. They use network data visualization throughout. Do I prefer working at Apple or Netflix? Well, I work at Apple now, so I'll say Apple. They're both wonderful places to work. I would take a job at either of those places if you're offered, okay? How old am I? I'm old enough to be giving a presentation to a bunch of people on a Friday in whatever this is. April? I think we're in April now.
Yes. Drew the bear. Someone was asking, who drew the bear?
Oh, who drew the bear? My wife, Meeks, who you can follow on Instagram because she's an amazing artist and does things like paints bears, but she paints a lot of other things too. Painted that bear. She painted it in watercolor, and a kind of watercolor called gouache. It's an opaque watercolor, and you should follow her on Instagram because she's great. Yeah. Someone asked, are networks like rumors? Actually, rumor modeling and representation of how information spreads through networks is a very important use of network analysis and network data visualization. Part of what I was talking about getting one message from one side to the network to the other is how they determine certain measures of power in a network. It's very important.
Is Verizon a network?
Yes, Verizon is a network. Verizon is what's called a telecommunications network. The way that your phone or your computer connects to other phones and computers is via wireless and cable connections, much like those maps that we were showing you. And except that along with the cables, they also use a lot of wireless cell phone towers to connect people.
How did you get into this job?
That's a
So
good
that's a very interesting question. So when I was in graduate school, I was studying ancient Chinese history. And while I was there, I got into making maps of ancient China. And when I started making maps, I realized I really liked making maps. And after I started making maps, I started making networks too. And then I started doing more traditional data visualization, like the bar charts and the line charts. And so what I found out was that there were lots of people who hadn't spent that much time working on data visualization. And so when I started looking around for jobs, I found out that there were quite good jobs for people who really understood complex network visualization like this. So first I worked at Stanford for 5 years, and there I got better at building all of this data visualization stuff. And then I applied for a job at Netflix. And at Netflix, they hired me because I was not only good at making network and map visualization, but other kinds of visualization and coding. And also I had written a couple of books on data visualization.
So, what kind of classes did you study in college to get into data visualization?
So remember how I was showing that chart that says people take these certain paths and you think, well, I'm going to go to high school and study computer science, and then I'm going to go to college and study computer science, and I'm going to go to get my master's degree in computer science. I didn't take that path. In college, I studied philosophy and Chinese history. And in graduate school, I studied Chinese history and environmental science. And it wasn't until I started to work a lot with data visualization that I really got into coding. So I took a very untraditional path, but you actually find out that out in the real world that a lot of people take those paths. And what you really find out is that if you really love what you're doing, and then you're going to get really good at it. And if you're really good at what you're doing, then you're going to find a job that's pretty, I can't guarantee it, but you can find a job. Most people who are really good at what they do can find a job doing that.
All right, cool.
At Apple, we look at how people use Siri, and we try to make Siri better for folks. It's got a lot of interesting problems and a lot of smart coworkers, and it's a good job. You know, these jobs in Silicon Valley are very interesting and very fun because you're solving problems that a lot of people have never even thought about before. And so you have to make new things all the time. And I think that's the most exciting part about having jobs like these is you are constantly making new things. So the website is Orbis, orbis.stanford.edu. I'll type it into the chat, orbis.stanford.edu. Oops, orbis.stanford.edu. And the technology I use to build that site is JavaScript is the coding language that we used for that. On the back end, we use something called Postgres, which is a SQL database that allows you to do lots of network queries very easily. And then for the data visualization parts of it, I use something called D3, which is a JavaScript data visualization library. And it is the top data visualization technology to use right now. So if you really want to do really amazing data visualization, you're going to have to learn D3.
How do we add a child to a grandchild?
How do we add a child to a grandchild? Let's go take a look at that in the code. Right?
Oh, yes.
So here's what's going on here. I don't want to overwhelm the folks for whom the coding is challenging, but if you look at it, you see how you have this object. So anything in this curly brackets is an object. That object has properties like a name. You can add properties to that, like children. So if we add children to it, you'll notice that, so this is my sister Nikki. She doesn't have any children, but if she had a child and it was named Igor, then that's how we add children to it, right? So take a look at it. Let me drag some things out of the way. We hit play real quick, and you can see that it shows up here. And I can do the same thing now with Igor, right?
All right, so with that, thank you, Elijah. That was awesome. And thanks everyone for all the wonderful questions. We have a few other things coming up. We do these open classes once or twice a week. And next week, we have something really interesting. We have someone who worked at Pixar for about 20 years and come talk about how making movies and animated movies actually are using a lot of coding. And then he actually won the Academy Award last year for engineering and technology, which is really cool. And then we also have, after that, we also have someone who come talk about AI and music, which is how do you use artificial intelligence to do music? Aside from there, for those of you who haven't come to our free introduction classes on coding and various other things, go try it out, and you can also sign up for our camps as well. Okay, all right. Thank you guys. And so good to see you guys again. I hope to see you guys again next week to talk about here the Pixar movies and how we make movies. All right, bye.